Properties of logarithms. The idea here is first we're going to look at when you need to change the base. Now, admittedly, on the calculators, especially if you have the newer software on them, they will allow you to do oddball bases like log base 7 of 6, that kind of stuff. The thing is, you won't always have that resource, especially students that are going into engineering and college courses now, oftentimes will not even let them use a graphing calculator. You get a scientific one and that's it. Okay, so the change of base formula can save you some hassle if that's all you're allowed to use as a scientific. But the idea of a change of base, it allows you to just do any base by changing things into one you already know. And the reason for this is the generic formula allows you to manipulate anything. So if I have log base a of x, I can redo that as log base something else of x divided by log base that same thing of a. Where that's useful is the ones you actually have on your calculator. So if you have log base a of x, I can just take log of x divided by log of a, or natural log of x divided by natural log of a. It'll give me that same value. Okay? So that's what the change of base formula allows you to do, is to just take ln of the regular number divided by ln of the base. Okay? So if I have log base 3 of 16 and log base 5 of 22, well, if I want to do this with common logs, I'm literally just going to take log of 16 divided by log 3. Go ahead and do that. What do you get?
2.52.
Close. 2 point what?
2.524.
Yep. Ask for 3 decimal places for 2.524. If you do natural log instead of common log, does it give you the same thing? Yeah, if you do ln of 16 over ln of 3, same thing. Go ahead and find log base 5 of 22 then. What do you get? 1 point what? 921. So not too bad. ln would give you the same values. Now, some of the properties of logarithms, and the reason is for these properties is because logarithms are essentially another type of exponential. They're the inverse of exponential. So a lot of your exponent rules are modified a little bit. You can apply them to logarithms. So normally, if I am multiplying two bases together that are the same, so if you say have x to the 6th times x to the 7th, what can you do with the exponents? Add them. So the idea here is if you're multiplying inside of the logarithm, that's the same as adding the two logs separately. Same type of thing when you deal with quotient. If you're dividing inside the logarithm, that's the same as subtracting the two logs. Numerator minus the denominator value. Okay, but it's got to be inside the log, not just dividing two logarithms. Power property allows you to, if you have log of something raised to a power, you can actually just bring that out front. So if I have log base anything of u to the n, I can move the n out in front of the log. Okay, that's where this ends up getting used a lot because it allows you to solve for issues when your variable's in the exponent. But it also allows me to rewrite logarithms in different forms, and that's where we're going to kind of focus during this section. So if I have ln of 10, and I want to rewrite that so it's in terms of ln of 2 and ln of 5. Well, what can I do to 10 to get 2 and 5? Yeah, multiply them. So this is just ln of 2 times 5. But then I want ln of 2 and ln of 5, so then I can just do what? Yep, ln of 2 plus ln of 5. So what would the ln of 5 halves turn into? Yeah, ln of 5 minus ln of 2. Stuff should be familiar, right? What about if I have, without the calculator, log base 7 of the 5th root of 7? Say that one more time. Yeah, the idea is because log base 7 of the 5th root of 7 is the same as log base 7 of 7 to the 1/5, and because that exponent can just move out front, you have 1/5 times log base 7 of 7. And what's log base 7 of 7? 1. So you just end up with 1/5. What about for the next one? Yeah, you're going to get 12 plus the 5 there, so you get 17. Now here's where they got to do actually finally a little bit of work, because they're going to take logarithms that are defined by a single log, and you're going to want to expand them out into the simplest individual logs possible. And then we'll also do the reverse of that. We'll take ones that are that are spread out and combine them together into one log. So through expansion, I'm going to split this out. I have log of 3x squared y. How many logs am I actually going to have when I simplify these all out? 3 of them. I'm going to have, what's the first log? Then what? Yeah. Now that second one's going to turn into log x squared, but the 2, you don't want it in the exponent, so bring it out front. So log x plus log y. So that would be the expanded form of that. For ln of square root of 4x plus 1 over 8, there, instead of adding, you subtract. So I have ln. How many pieces, how many ln's am I going to have? Just 2. I'm going to have ln of the top minus ln of the bottom. But I do actually need to get any exponents out of there. And I do have an exponent. What exponent do I have? 1/2. So I'm going to realize that that's raised to the 1/2, and I'm going to put that out front. So I have 1/2 ln of 4x plus 1 minus ln of 8. Now can I split this up at all, the 4x plus 1? No. If it's multiplication in there or division, you can split it up. If it's addition, you're just stuck. Now, that's expansion of logarithmic expressions. You also have condensation. In other words, condensing logarithmic expressions. The idea is to get down to a single logarithm. Now, in order to do this, you need logs with nothing in front of them. So the first thing I got to do with the 1/3 and the 5 is what? Yeah, move them to the exponent. So the idea is this is log of x to the 1/3 plus log of x minus 3 to the 5th. So when I consolidate these together, I'm just going to get log of what? X what? Now this is raised to the 1/3, right? So I'd first write that as cubed root of x times, because it's plus, it's going to be times x minus 3 to the 5th. You don't need to simplify inside the logarithm. It just basically means put everything together, though. On the next one, same thing first. Move up anything that's an issue out front. So ln of x minus 4 to the 4th minus ln of x squared. Then what is my single natural log here going to look like? Yeah, x minus 4 to the 4th over x squared. What about the next one? Do I move the 1/5 up first? No, not in this case. I'm just going to take log base 3 of x and log base 3 of x minus 2. Because I'm adding them, what can I do? Multiply. So I'm going to leave the 1/5 here for now. Combine those together into a single logarithm. So that's going to give me x squared minus 2x inside the log. Then what? Raise to the 1/5, which means what? 5th root. So this is log base 3 of the 5th root of x squared minus 2x. Questions on any of it? Make sure you go back and look through sections 1, 2, and 3. I'll go over any last minute questions tomorrow, and the practice quiz is on Friday.